may look a little bit different to you, mainly because this isn't quite a multiple choice, nor is it a full-fledged formal proof, because it's what they're calling a partial proof. They give you a bunch of stuff, and they want you to fill in some missing information. They want you to fill in 4 reasons here. And what they're asking us to do is prove that 2 segments are congruent. And if you remember, a couple times I've talked about this idea of corresponding parts of congruent triangles, that the whole entire point of proving triangles congruent is to do this, right? To show that pieces that you wouldn't normally be able to explain are congruent, by showing that this entire red triangle is identical to this entire blue triangle. Then you can get at this. So that's the catch with this. Whenever you see prove a set of sides or a set of angles are congruent, you're really doing a triangle proof, okay? And then it's one extra step, and you can see that here. Step 8 is they're going to show those triangles are congruent, and then the last step is, oh, these things are congruent. We'll deal with that last. But let's go through it. 1, they just list off that given. Great. 2, they list off these perpendicular givens. And we know, well, if AB is perpendicular to BC, a right angle is formed at B. And the same thing with DE and EF. There's a right angle here, okay? And step 3 is angle B and angle E are right angles. And well, how do we know that? Well, that's just the definition of perpendicular. Okay? Well, then the next thing they go to say is, oh, well, those angles are congruent. Huh, so they're not going for a hypotenuse leg, right? They're setting up a pair of congruent angles. And then they list another given. And let's put that into our diagram. I'll do it in black. They say BC. All right, this side is parallel to FE, to this side. And if I really wanted to, I could kind of extend them if I had to. But I just want you to see there's a Z here, okay? There's the Z, and I guess I'll do it in green so you can see it better. There's the Z. And we know that this angle will be congruent to this angle, and those are what we call alternate interior angles, all right? And in fact, that's the next step that they do. They say angle BCA, this one here, is congruent to EFD, that angle we just pointed out there. And we already went through that reason. For us, I'm going to say alternate interior angles are congruent. And if we want to be extremely precise, it's only when, so alternate interior angles are congruent when parallel lines cut by a transversal. They don't really give us much room, so I think this is sufficient, okay? So there's another pair of congruent angles, and then they list the last given, right? And I'll do this one in red, that AB, right? This here is congruent to DE. And this is another angle side, right? That side is opposite one of our congruent angles. So to show that these triangles are congruent, that's the angle side postulate. Okay, well, now that I've established, and I'm going to erase all this, all right? Now I've established that this top triangle is congruent to the bottom, right? Triangle 1 is congruent to triangle 2. Well, the last thing we see is AC, so let's highlight that. This side, well, that's the side that corresponds to FD in the other triangle. And if I have congruent triangles, okay, if I have congruent triangles, then the corresponding parts must also be congruent. And that's our reason for saying this final step is that corresponding parts of congruent triangles are congruent. Right? That's corresponding parts of congruent triangles are congruent. And that's CPCTC, and that abbreviation is sufficient.